Hello everyone, this is Mr. Slomka, and this is a video on section 11.1, normal distributions, and this is part 2 of 2. And so today what I wanted to do is I wanted to talk to you a little bit more about normal distributions, which are our bell curves that we were looking at in the first video, but we're going to extend the problems to some that are a little bit trickier. So what we're going to do is we're going to continue to talk about normal distributions, but we're going to add in a new tool which is called standard normal distributions, and we're going to extend that with something called a z-score. So let me show you exactly what I mean first, and then I'll go into why these things exist. So we're going to skip down here to our first example problem here for a couple of seconds, and then we'll jump back. Right here, it says that we're talking about a survey of heights for some women, and we find out that the mean height is 64.5 and the standard deviation is 2.5. Now all of this sounds very normal. This is exactly what we had seen in the first video, and so what we would typically do is draw ourselves a bell curve. We would take our mean of 64.5 and put it here in the middle, and then we would use our standard deviation to add 2.5 and increase that height, and then we could subtract 2.5 and decrease the height. You can see that there is a lot of women that have this average normal height. There are some women that are particularly tall, and there are only some women who are particularly short. So all of this feels very normal. Get it? Normal. The thing that is going to be tricky about this problem is the question that they ask. So the question they ask happens to be about the number, or a woman specifically, that is 58 inches tall. So now if you look carefully, you'll notice that I never wrote down the number 58, and so that's a problem. In the part 1 notes, we would have been given a number that showed up on our bell curve. But in this portion of the notes, we will be given a number that does not show up on our bell curve, and that is where the problem exists. We need a new tool to deal with this new situation. That new tool is something called a standard normal distribution and a z-score. So here's the deal. If you have a distribution like ours down here that is not working very well, then what you can do is you can change your normal distribution into a standard normal distribution. This is going to be a very big help to you because it will relocate the mean to 0, and it will make the standard deviation 1. And so it's going to change the values a little bit in order to make them very easy to work with. And the way that you perform this change right here, so the problem becomes easy to work with, because right now it's not very easy to work with, these numbers aren't matching. In order to make it easy to work with, we are going to use a formula called the z-score formula that you have right here. This is super easy to do. Any value that you're curious about, you are going to subtract the mean from it, and you will divide by the standard deviation. But then, right down here, this formula is only half of the z-score process. The z-score process also requires you to have something called a z-score table. This is my z-score table, and you can find it on my Google Classroom. The z-score table is like a paper calculator. If this looks big and scary to you, don't worry too much about it. It is the slim column of numbers on the left side and the small row of numbers at the top that mean the most. And this is actually in the middle where all the answers are. There's 2 pages of this, and so we're going to be using this. If you have not already printed off your z-score table, please do so now so that you can practice using yours while I use mine. Okay, let's go back to our problem. So as we had seen, we were interested in a survey about women's heights, and we were interested in particularly women that were at most 58 inches tall. So these are going to be particularly short women. These are women that are not very, very tall. And so what we want to do is we would love to use our bell curve, but there is no 58 on it. And so instead what we're going to do is we're going to use our z-score formula. You will use your 58, and that will be our first number that we write down, but it won't be the only one. You also need to make sure you know the mean, which we have. It's 64.5. And you need your standard deviation, which we also have. It's 2.5. Now that you've collected that information, now what you can do is you can start typing stuff into your calculator. Now I have a very strict rule about this, and I need you to make sure you follow. No matter what, whenever you're working with your calculator on these problems, you need to make sure you round to 2 digits after the decimal point. So when I use my calculator right here and I do my subtraction first and then my division second, I actually get negative 2.6. But I want 2 digits after that decimal point. So that means I'm going to call this negative 2.60. And the reason for that is so that the next step works properly. What we have done right here is we have taken a problem that was about women who were less than or equal to 58 inches tall, and we have now changed it into a problem about values that are less than or equal to negative 2.60. So this number is a little bit smaller and a little bit more manageable for us. And the other really great news is now what we can do is we can use our z-score table to get our final answer. No calculator necessary for this step. So now to begin with, I want to focus on the column. And so we're going to be looking at the column and we're going to try to find the perfect sweet spot for us. And so let's start. The number that we're very interested in is negative 2.60. I want to find that number on my z-score table. The first thing I notice about the number is that it is negative. One of the pages of my z-score table in the far left column has numbers that are positive. That's not the side for me right now. I want the side of the z-score table that has negative numbers, and I find it right here. Next, after the negative sign, you'll notice that there's 2 digits. My first 2 digits that I have is a 2 and a 6. So I want to find that 2-6 combination here. Not 3s. These are no good. Here's the 2s, and here's the one that's got the 2-6. Now my last digit that I have, remember I said that it always needs to be 2 digits after the decimal point, and this is why. My last digit that I have is 0. And the way that you're going to find that last digit is by looking across the top right here. My last digit was 0, and it happens to be that guy right there. So now here's how we're going to find our final answer for this problem. I want you to come across from the negative 2.6 that we had talked about earlier, and then I want you to come down from the 0 that we just got done talking about. When you come across and down at the same time, you end up at the perfect final answer. And that perfect final answer is going to be 0.0047. That is the answer that we are after. 0.0047, or if you'd like, 0.47%. It turns out that only a very small percentage of the population of women in the study were less than or equal to 58 inches tall. So most women were much taller than that, and so this guy right here represents only a small population. You could see that on our bell curve that we had. Even though we didn't have the number 58 on there, we did have something close. 57 is right here, and if you notice, 57 is very close to this tail of the curve. It is not associated with any of the tall bars that we see over here towards the middle. All right, so question B right here is going to follow about the same way. So now this time what we're interested in is we're interested in talking about the women who are at most 70 inches tall. So now 70 itself is a pretty tall number, and that would make for a pretty tall woman. But remember that we're not just interested in the 70-inch tall women. We're also interested in any woman that would be less than 70. That's what the at most part means. So that could also include a lot of average height women, and it would also include some of the shorter women that we have in our study as well. So this question right here is asking for a large quantity of women. We should expect to get a percentage that is much higher than our last answer was. Let's calculate our z-score first. The number 70 is not on our bell curve, even though we can get close. And because 70 is not on our bell curve, we're going to have to use our z-score. So I will start with the 70, and this time I'm going to subtract 64.5, and I'm going to divide by 2.5. Remember that when you do this work, your answer needs to have 2 digits after the decimal point. And this time our answer is 2.2. I'm going to include that extra digit of 0 at the end here just to make sure that we can use our z-score table properly. Okay, so our old question used to be about a woman that was less than or equal to 70 inches tall, and now what we've converted it to is we've converted it to a question about the number 2.20. That number is much smaller and more manageable, and it's a number that shows up on our z-score table. Let's get our table going. So now our answer, once again, or our number that we had was 2.20. There are 2.2s that we see on our table right here on the side that we were just working on, but they're negative, and so we don't want those ones. We want to flip over to the positive side this time. When we're flipping over, we want to find, once again, the first two digits in the column. I can find myself 2.2 right there. I'm going to be moving across from that 2.2 in order to find my answer. Up at the top is where you're going to find your third and final number. My last number was a 0. I can see that 0 right here, and that means that I will be traveling down from the 0 to find my answer. When I travel both across and down, I get this answer right here, 0.9861. All of the answers to our questions today will come from that table, so you need to make sure that you have that paper printed off and next to you so that you can access it often and conveniently. So now remember what I was saying earlier. A woman that is 70 inches tall is rare. There are not that many women like that. But this question is also referring to women that are less than 70 inches tall. So our population of women that are 70 inches tall is not 98%. This is going to include a lot of women that are shorter than 70 inches tall, but it will also include the women that are exactly 70 inches tall as well. There's our second answer. Okay, so the trickiest part of these problems is that a lot of times people stop after they use the formula and they never use the table. Please make sure that you're using the table in order to get your final answers right here. You need to make sure that you're doing both parts of the z-score process and not just the first convenient portion. Let's do a tricky problem. So now on the back side, what we have right here is we've got basically the exact same question again. This time it's talking about 70-inch tall women, but we have changed the words to at least. So now what this means is that we are talking only about women that are 70 inches tall or taller, a greater than symbol. If we were going to look on our bell curve, we would have to estimate where the 70 is because we don't have a good tick mark for it. And because we're talking about greater thans this time, we would be interested in all of these women over here. This should be a very small percentage of the population. We're only talking about the extremely tall women right now. If I'm using my normal z-score technique, it's going to go a lot like it went last time. I will use the same mean and I'll use the same standard deviation. And when I do that, I'm still going to get 2.20. And when I go to my z-score table, 2.20 is still going to give me a very large percentage, 0.9861. I know that this answer is too big. 98% of the population couldn't possibly fit into this small shaded region. So that means that this answer is not good right now. And the reason why is if you take a look at the drawing we made and the drawing that is given to you at the top of the z-score table, you'll notice a small difference. The difference is that in our drawing, the shading was to the right of the border. But on the z-score table, it only works when the shading is to the left of the border. So that means that our table is not perfectly suited for the problem. But luckily, there's a quick shortcut that will help you get to your perfect final answer. All you need to do is tag on one extra step. And that step is outlined for you right here. Once you've come up with your answer that seems unreasonable, you are going to do 1 minus the answer. In the last chapter, we would have called this a complement, or the opposite of the idea that you just presented. Another way to think about this is that this 100 represents the entire bell curve, and this subtraction represents getting rid of the part that you don't want, so you can just focus on the portion that you do want. When you do this small piece of work, you will end up with a far more reasonable answer. This answer did not come from the z-score table, but rather came from our calculation right here. It is only a very small percentage of the population that is so tall that they are 70 inches tall or taller. Please make sure you are watching out for the problems that have the greater than signs. They look almost identical to the easier problems that we saw on the front side of the notes, but they require an additional step here at the end. This is 11.1 Part 2 notes of 2. Please move on to working on your worksheet and send me an email if any of this was confusing or strange to you.